I hope you'll find this stuff useful. Just know that I gear most of my stuff to elementary and middle school, so if you're a high schooler in here, hopefully there's a way that you'll figure out how this can be applicable to your students. But yeah, so let's talk about the electromagnetic spectrum, right? So when you are tuning your radio, when you are sending a text message, or you're watching TV, or maybe you're popping popcorn, you are using electromagnetic energy, okay? And so there's this whole range of electromagnetic energy, this large spectrum, and of that large spectrum, we only see a tiny little portion of it, and that's called visible light. And so there's different energy levels that range from radio waves to gamma rays, and what happens is these different light energies give us insight into what's happening in the universe, because we only see visible light, right? But all of this energy is radiating out in the universe. And so there's little hidden secrets in each of these energy waves that astronomers use to look at the light to see what's happening in the universe. There's information about the life of stars and galaxies. It's all encoded in these colors of light, okay? And so one way we do this is we use filters, because it can block out certain energy levels of light and allow other energy lights to pass through the filters. And so we're going to explore filters and how they help and aid an astronomer in doing his job, and what are the hindrances and what are the problems with using filters. So the first thing that we're going to do is we're going to build a filter. So this is visible light only. It's using a filter that is only letting visible light emitted from the sun in this image. What is being highlighted in this picture right here? What do you notice about this black and white picture? What? The spots, yeah. So those are sunspots. So this is a really good filter, just looking at the sun in the visible light spectrum, but of course we're dimming a lot of that light because the sun's very bright, to just highlight the sunspots. And so sunspots, if you aren't aware, they're planet-sized regions of twisted, chaotic, magnetic field lines, okay? Now the next image here we have a blue light. So this is a very specific blue wavelength of light. So the filter is blocking out all the wavelengths of light except for a very specific line. The wavelength is known as calcium K. And this is what you get when you use a calcium K filter. And it highlights these magnetic structures. These bright regions are where the magnetic fields are really strong and intense. Now this last picture down here, this again is using another filter. This is using it's only letting in a very specific wavelength of light. This is helium. And so this is letting radiation come through, where you see these dark regions. So you have radiation coming out from the sun. Well, some of that radiation gets absorbed by the sun's atmosphere. And so these dense regions is where the radiation, there's no more radiation to make it through to the cameras. That's where these dark areas are. The last one, this is X-ray. So this is observing X-ray radiation from the sun. And so these are all found in different layers of the sun. This is the photosphere. So if you have your pictures here of the sun has these layers. The outer area is the corona. That would be where this X-ray image is found. And then you move down a little bit further into the sun and you get to the chromosphere. This is the upper chromosphere. This is the lower chromosphere. So this helium image would be on top of the blue image. You're going further into the chromosphere of the sun, okay? It's like you're stacking these images. And then underneath all these pictures would be the photosphere. That's the next level. And that's the only layer that we can see into the sun. Anything past that is too dense for scientists to be able to observe and see. So tell me what you notice about these images. Can you see similarities between the different filters? Yeah? Yeah, are different, the filters are different, where you see bright regions or lighter areas or darker areas, they're all magnetic field areas, right? All where the sun has intense magnetic field activity going on. And so this is kind of what our team of scientists do. So the difference with this and our telescope, so this is from our telescope. Let's see, I don't know. So our telescope does not look at the whole disk of the sun. Our telescope is looking at less than 1% of the sun's surface in very high definition. So these images are of a very small region on the sun. And you can see the size of Earth compared. So our telescope can see a 90-mile area. 90 mile might sound large, but in respect to the whole sun, it is a small, small area. And so here again is what our telescope would look at the sun in. We have instruments that have filters on it. One is a universal bifringent filter, and I call it a Lego because that's what it looks like to me. It's this big white box with knobs on the top, and they can rotate the wheels on that instrument to different filters, so they can decide what color filter they want to use to look at the sun in that day. And so this helps us isolate regions. If you want to look at the magnetic field strength on the sun, well, what filter are you going to use? I'm going to look at this one right here. If I want to look at the temperature on the sun, I'm going to use this filter here. And so there you're building this piece of the puzzle and you're stacking these images to get this complete representation of what's going on through the sun, through the different layers. Any questions?
But this is digitally done.
Right, so this has been enhanced on the back end when they do our data reduction. They fine-tune the data that they collect from it. So this isn't raw. Oh, are we talking about, is it my photocopy? It's probably my photocopy. No?
Probably.
From the,
Scans.
Maybe. Yeah. So if you ever come to our telescope, everything we look at is in black and white. We use those old CCT monitors because they're very good for highlighting dark regions and light regions on the sun. Color is added at the end when they get to the data reduction and they're getting it ready for scientists.
It's open to the public?
It is, yeah. And so when I have my table up there, I'll have information about that. But yeah, we have a visitor center, museum. We give tours of the telescope. If they're actively observing, you're going to get a live image on the monitors. It's super cool. So any questions?
What kind of filters over the telescope? Like, it's curious.
This is what you're seeing right here. So they have a calcium K filter. They have a sodium filter. So this is another whole thing. It's probably more high school. Do you guys play with the spectrum and heating up tubes? Well, I'm losing it. Yeah, like if you have a hydrogen tube, helium. Yeah. So that's kind of what we're doing there. We're looking at there. So when you have a hot body like the sun, and that light travels through a gas, like say sodium, the sodium, right, we see a continuous spectrum, right? Do you guys know that? Light is not the absence of color, but it's all the colors of the rainbow. So we see a continuous spectrum, but when you have that light from the sun pass through a gas, that gas is going to absorb some of those colors and it's going to let some of those colors through. And that's how you can determine what stuff was made out of, because each of those elements have a unique fingerprint. And so we use helium, a filter for just looking at helium. It's a specific wavelength where you can find it that's going to highlight a certain feature. This is sodium, this is calcium. So I don't know if I'm explaining this well, but I hope so, if that makes sense. So there's not helium in the telescope, there's helium on the sun. And so we're using filters that are tuned to that specific wavelength of helium. So we're using filters that will look at a specific wavelength of light. That's tuned to a specific wavelength. Yes, good question. Any other questions?
So how fine is the resolution of the wavelength?
I already asked you. That's a science question. They,
Just look at the colors, man.
yeah.
No, I'm kidding.
They have answered this question and they told me, I just haven't answered it. What's that? Yeah. But yeah,